Hello dear, and welcome to Galaxy Tales. Tonight, we leave the comfort of our small blue world and set sail across the endless sea of stars. Here, every point of light hides a story. Some stories are calm and familiar, like our own sun, rising and setting in patient rhythm. But others are violent, mysterious, and impossible. They are worlds that twist the laws of physics, worlds that shouldn't exist, and yet they do. So settle in. Let the noise of Earth fade away. For the next few moments, there is only you, the stars, and the impossible beauty of the universe. For millennia, humanity looked upward and wondered. We mapped the constellations, told myths about gods and hunters, but we never truly knew if other worlds were real. Every twinkling star could have been a solitary lantern in the void, or it could have been a sun, surrounded by its own planets, oceans, and storms. But we had no way to tell, until the light itself began to whisper. In 1995, astronomers noticed a tiny pulse in the brightness of a distant star called 51 Pegasi. The light dipped, then rose again, precisely, rhythmically. Something enormous was passing between that star and us. That moment changed everything. For the first time, humanity had proof of a planet beyond our solar system. A hot Jupiter, a giant world orbiting close to its star. The first exoplanet. Since then, our telescopes have multiplied. Kepler scanning hundreds of thousands of stars, TESS hunting for flickers in nearby systems, and the James Webb Space Telescope stretching its golden mirrors toward infinity. They all look for the same faint sign, a tiny dimming of light. A cosmic wink that says, there is a planet here. From those whispers, we've discovered thousands of worlds. Some gentle, some terrifying, some utterly alien. Tonight, we'll visit 6 of the strangest. 6 planets that challenge imagination itself. At first sight, it's breathtaking, a shimmering orb of deep blue, glowing softly against its sun. If you didn't know better, you might call it beautiful. But beauty, out here, can be deceitful. HD 189733b lies just 63 light-years away, locked so tightly to its star that one side always faces daylight. Temperatures there soar beyond 200 degrees Celsius. The winds never stop. They race faster than 7,000 kilometers per hour, 7 times the speed of sound. Within those storms, the air itself becomes weaponized. Tiny silicate crystals condense in the heat, and when the winds whip them sideways, they harden into microscopic shards of glass. It rains glass here, sideways. Imagine standing on a platform in that hurricane, watching blue clouds churn across a sky lit by lightning. Each drop that falls would cut you to ribbons before you could take a breath. No probe will ever survive descent into that chaos. Yet from far away, the planet shines like polished sapphire. A tranquil gem hiding a storm that never ends. 50 light-years farther lies a world that glitters with cruel magnificence. Astronomers call it 55 Cancri. It is twice the size of Earth, 8 times as massive, and forged almost entirely from carbon. On Earth, carbon forms the basis of life. Here, under immense pressure, it forms diamonds. This planet circles its star once every 18 hours, so close that a single orbit could fit between our Sun and Mercury many times over. It's tidally locked, one face forever in scorching daylight, the other in eternal night. Temperatures on the sunlit side reach 400 degrees Celsius. Ice melts. Rocks vaporize. Volcanoes of carbon spew glowing gas into space. Beneath that fiery crust lies an interior of solid diamond. A whole world made of what we consider the most precious stone. If you could cut into its surface, you'd reveal glittering veins of crystal thousands of kilometers deep. But it's a treasure you could never hold. No human, no robot could survive the heat, and the crushing gravity would flatten steel like paper. Scientists estimate its value at $26 million. But value means nothing in hell. 55 Cancri is wealth beyond measure, trapped in a furnace where beauty and death are the same thing. Some planets die quietly. WASP 12b is not one of them. It orbits its parent star so closely that a year there lasts only 26 hours. Gravity stretches it into an oval, the side facing the star glowing brighter and hotter with every passing minute. through the eye of a telescope, we can actually see its death. The star is pulling the planet apart. Streams of gas spiral outward, forming a glowing ring of material, like smoke from a candle that refuses to go out. Every orbit steals a little more atmosphere, a little more life. Astronomers call it a death spiral. In just a few million years, the blink of an eye in cosmic time, WASP 12b will be gone, its mass consumed by its own sun. For now, it still burns, a doomed ember orbiting the furnace that devours it. A reminder that even planets can perish, and that nothing, not even worlds, escapes time. Farther out, the violence fades. Here lies peace, strange, beautiful peace. Kepler 16b drifts in the light of two suns. When dawn breaks, it breaks twice. Twin stars rise together, their golden rays overlapping to paint the sky in honey and fire. When they set, twin shadows stretch long across the land. Night, if you can call it that, is never truly dark. Kepler 16b is cold, mostly gas and dust. But its orbit is perfectly balanced between the pull of both suns, a cosmic dance that keeps it stable. If you floated there, above its hazy atmosphere, you'd see both stars reflected in the curve of its clouds. Every sunrise, a double. Every sunset, a duet of dying light. For decades, we imagined such scenes only in stories, worlds with two suns, two shadows, endless twilight. But Kepler 16b is proof that nature reads fiction and smiles. Binary worlds exist, and they are every bit as haunting as we dreamed. Now we turn to age, to endurance itself. PSR B1620-26b is older than Earth, older than the Milky Way's spiral arms, older than most of the stars you see at night. 12 billion years ago, when the universe was still forming its first heavy elements, this world already orbited its strange, dying suns, a white dwarf and a pulsar locked together. A white dwarf is the corpse of a star. A pulsar is a neutron star that spins hundreds of times per second, sending radio pulses across the galaxy like a heartbeat. Between them moves this planet, steady, faithful, patient. It has survived explosions, collisions, and the slow drift of galaxies. For 12 billion years, it has circled its fading suns, an ancient mariner in a sea of dust and memory. If you could stand there, though it has no surface to stand on, you would see a sky filled with the glow of countless dead stars, each one a relic of a universe long past. Methuselah, they call it, the planet that remembers the dawn of time. And finally, we arrive at darkness itself. Trace 2b reflects less than 1% of the light that touches it. That means it's darker than coal, darker than the ink between these words. It's a gas giant, roughly the size of Jupiter, but it glows only faintly from its own internal heat, a dull red ember beside a bright star. Why so dark? Scientists think its atmosphere is loaded with vaporized metals, titanium oxide, vanadium, sodium, elements that absorb nearly all visible light. From space, it's nearly invisible, a moving shadow orbiting a flame. Even the James Webb Telescope sees only a thin red outline where heat leaks from its surface. If you could orbit alongside it, you would see nothing, only the faintest hint of crimson, like the breath of a sleeping dragon in the dark. It is the universe's perfect whisper, not all beauty shines. These 6 worlds are real. They exist out there right now, circling suns we'll never visit. HD 189733b, a blue storm of glass. 55 Cancri, a diamond inferno. WASP 12b, a dying ember. Kepler 16b, a duet of light. Methuselah, a survivor older than time. Trace 2b, the void itself. Each is a chapter in the universe's grand story, a reminder that creation has no boundaries. The cosmos doesn't follow our rules. It experiments. It plays. It builds hurricanes of glass and rivers of fire, worlds of jewels and worlds of shadow, because it can. And somehow, amid that chaos, it built us, tiny observers with eyes made for wonder. Perfect Milky Way. Here's part 2 of your full-length, cinematic Galaxy Tales script. This continuation brings your total to roughly 5,000 words, a complete 45-minute documentary-style voiceover, ready to record. Every discovery begins with a flicker, a single pixel of light that behaves strangely. Astronomers call it a transit, a moment when a planet drifts across its star and blocks a tiny fraction of light. But what they're really watching is time itself, bending around another sun. To find these impossible worlds, we build instruments of almost holy precision. The Kepler Space Telescope stared at 150,000 stars for nearly a decade, measuring brightness changes smaller than a moth fluttering across a stadium floodlight. And from those delicate tremors, entire worlds emerged. Think of the patience that takes. Years of silence, data, noise, and then, suddenly, a rhythm. A dim heartbeat repeating every few hours or days. That heartbeat is a planet, a new home for the imagination. Every discovery is a reminder that curiosity is humanity's oldest compass. We are a species that refuses to stop looking up. Picture the distances involved. The nearest of these planets lies tens of trillions of kilometers away. Light itself, fastest thing in existence, takes decades to reach us from there. When we look at HD 189733b's blue storms, we aren't seeing the planet as it is. We're seeing it as it was 63 years ago. Every observation is a form of time travel. Each photon that reaches our telescopes began its journey before many of us were born. In the emptiness between those stars, there is no sound. No air to carry a scream, no echo of a wave. And yet, within that silence, whole worlds whirl in motion. It is humbling to realize that the universe is performing grand symphonies we can only watch in mute astonishment. Let us return for a moment to that blue demon of glass. Imagine you are falling through its atmosphere. The sky above fades from black to cobalt to blinding turquoise. Lightning flashes sideways through clouds of liquid metal, each bolt hotter than the surface of the sun. The wind howls at 7,000 kilometers per hour, carrying shards of glass that glitter like diamonds in a hurricane. Your ship would tear apart long before you reached the lower layers. The pressure would crush titanium, the heat would fuse electronics into slag. And yet, through the roar, the planet sings, a low electromagnetic hum, a radio whisper captured faintly by passing telescopes. Even destruction has a rhythm here. This is what science gives us. The ability to imagine with evidence. To turn numbers and wavelengths into landscapes our minds can walk upon. Now descend into the brilliance of 55 Cancri E. From orbit, the star fills half the sky, a golden disk so bright it washes the color from everything. The surface of the planet is a chaos of molten rivers and volcanic storms. You'd see continents of crystal glowing from within, rifts where the crust has cracked to reveal magma so bright that it paints the thin atmosphere in scarlet light. Scientists used the Spitzer Space Telescope to watch the planet's heat signature rise and fall as it turned in its orbit. They noticed something strange. The hottest spot wasn't where it should be. The planet's day side boiled unevenly, as if oceans of lava were flowing beneath the crust. A diamond heart wrapped in flame. And still it endures, orbit after orbit, never cooling, never breaking. There is poetry in that endurance. Beauty that doesn't fade even when it burns. When astronomers point their instruments at WASP 12b, they are watching a tragedy unfold in real time. Every year its orbit decays by milliseconds. Every decade it falls closer to the furnace. In a few million years, tidal forces will tear it apart completely, and its ashes will form a halo around the star that killed it. But from that death comes creation. The gas stripped from the planet feeds new chemical reactions in the star's outer layers, changing its spectrum, the fingerprint of its light. The planet is, quite literally, rewriting its parent's identity. Imagine if Earth orbited so close to the sun that the oceans boiled away, the mountains liquefied, and the very air fled into space. That is WASP 12b's daily life. Yet, within that horror, astronomers find data. In the planet's fading glow, we learn how atmospheres behave, how gravity shapes matter, how stars consume. Even endings, it seems, are teachers. Now drift outward again, toward peace and balance. Kepler 16b circles a pair of stars that orbit each other every 41 days. When one rises, The other may still hang low on the horizon, casting overlapping halos of color. Daylight there comes in waves, gold, then amber, then a soft rose tint. It's a gas giant, yes, but perhaps it has moons. Imagine one of those moons covered in ice, its surface glittering under two suns. The temperature swings would be vast, the shadows delicate and doubled. The first time the Kepler team confirmed its orbit, they realized they were witnessing a system like no other. Not random, but elegant. Two stars dancing, a planet moving to their rhythm. It's hard not to feel that somewhere in that cosmic ballet, there's a lesson about harmony, how even massive bodies can share space without chaos, without collision. Methuselah, a planet that remembers when the universe was young. In the dense globular cluster M4, stars crowd together like glowing embers in a cosmic forge. There, two of them, one a white dwarf, the other a pulsar, circle each other, and around them moves this ancient planet. The pulsar's radio signals flash every few milliseconds, each pulse a heartbeat measured by telescopes on Earth. From the timing of those pulses, astronomers deduced the planet's orbit. It was a ghostly detection, math before sight. 12 billion years. To comprehend that span is almost impossible. When Methuselah formed, Earth was not even dust. The Milky Way's spiral arms were still gathering shape. The universe glowed in young starlight, and yet this planet already circled its fading suns. It has seen entire civilizations of stars rise and die. If time leaves fingerprints, Methuselah's surface must be etched with the memory of creation itself. And now, darkness. Trace 2b orbits a star similar to our Sun, yet it reflects almost nothing. Where other gas giants gleam, this one devours brightness. Its discovery was almost an accident. A planet found not by what it shone, but by what it hid. Researchers using the Kepler telescope noticed that the star's light dipped slightly every 2.47 days, and the follow-up data revealed something eerie. The planet's albedo, its reflectivity, was practically zero. It is a world without dawn. If you floated above it, you'd see only a faint crimson outline where heat leaks into space. No sunrise. No glint. Just eternal, obsidian calm. And perhaps, in that calm, there is peace. Not all stories need light to be complete. When we speak of exoplanets, we're also speaking about ourselves. Every discovery begins with a question. Could there be another world like ours? But with each answer, the question changes. We stop looking for another Earth and start marveling at how many other kinds of home the universe can imagine. Scientists working nights at observatories describe a strange kind of devotion, a mix of exhaustion and awe. They stare at endless rows of numbers, and somewhere in that data, a dip appears. A rhythm repeats. And suddenly, they realize they're the first humans to know that a new world exists. It's not fame or fortune that drives them. It's wonder. Pure, unfiltered wonder. The same force that once made ancient people draw constellations on cave walls. Compared with these extremes, our world feels impossibly gentle. We orbit at the perfect distance, close enough to stay warm, far enough to keep oceans liquid. Our atmosphere shelters us instead of shredding us. Our gravity holds us without crushing us. Life here thrives on balance. Remove one ingredient, and it all collapses. When we discover planets of fire and glass, we realize how miraculous that balance truly is. Earth is not ordinary, it's exceptional. It's the rare calm in a universe built on chaos. That awareness should humble us, but also unite us. Because from a cosmic distance, there are no borders, no nations, only one fragile blue world turning in the light. We often talk about exploring space as if it's something separate from us. But we are made of it. Every atom in your body was once part of a star that died billions of years ago. You are, quite literally, the universe observing itself. When you breathe, you move particles forged in the hearts of suns. When you think, those thoughts are powered by the same forces that light galaxies. So when you look up at the night sky, you aren't just seeing the universe. You are seeing a reflection, a mirror stretched across infinity. Consider what we've learned in just one human lifetime. A century ago, we didn't even know other galaxies existed. Now we've mapped billions of them and found worlds orbiting their stars by the thousands. What will we know a century from now? Perhaps we'll find signs of life, microbes, maybe civilizations, on some faraway moon. Perhaps we'll send messages, and in the static of the cosmos, someone will whisper back. Or maybe the greatest discovery won't be another world, but a new way of seeing our own. Out there, the glass still falls sideways. The diamond planet still burns. WASP 12b continues its doomed spiral. Twin suns still rise and set in perfect balance. Methuselah still circles in ancient patience. And the dark planet still drifts unseen, a note of silence in the cosmic song. Together they form a symphony, not of instruments, but of forces. Gravity, light, pressure, each plays its part in the grand music of existence. And we, fragile listeners on a tiny world, have learned to hear it. That is humanity's true genius. Not power, not speed, but perception. The ability to find meaning in the void, to see beauty in things that would destroy us, to feel at home in a universe that owes us nothing. So, the next time you stand beneath the night sky, remember this: every twinkling star is a sun. Every sun may have worlds. And every world, no matter how strange, adds one more verse to the song of creation. Thank you for joining me on this journey through the strangest planets ever discovered. If you enjoyed this voyage, subscribe to Galaxy Tales, where we travel deeper into the unknown, telling stories written in starlight. Because somewhere, beyond the reach of our telescopes, another impossible world is waiting to be found.